Howdy. So we have a Jeep ECU here to repair. Customer claims that it has a misfire. I can't remember which cylinders, but customer said that they opened it and they did not see any issues. So we're gonna open it and take a look. Typically, when these have misfires, you will see blown up coils, drivers. So not seeing anything is not good. That means it might be something else. But first, I want to check the edge to make sure nothing got damaged when they opened it, because these are very easy to damage as you open it. So let's go into the microscope view here, take a quick look around. Okay, don't see anything bad so far. Looks okay. These guys right here are the main culprits that like to get damaged. So that's not bad. And also, this stuff along this edge here likes to get damaged. Don't see anything. I think we're going to be good. So this is one of the older units. I guess this is from like a '07 maybe. I'm not sure, but it is the older style. Uh, let's go ahead and take a look at the coil drivers while we are under here. Now I don't remember which one is which, and I don't remember what issue they were having. But if we look, I don't see anything visually wrong with any of them. Let me see if I can get a little bit better view here. Trying to get some of that light glare off of there. And visually everything looks good. So let's go ahead and get the meter out here and check the drivers, see if they're any good. I like to do that by checking the resistance across the base and the emitter here. It should be usually about 14 to 17k ohms. So this one is 16. Let's check this next one here. 16, that's both perfect. Third one is 16. Come over here to these. They are 16 as well. Another one. All right, so far the driver looks good. Um, the resistance value between the base and the emitter anyway. Let's go ahead and check the base and collector now. Sometimes this one will be bad. So it's 200k, which is about right. This will fluctuate quite a bit, so you just want to look for consistency between it. And they were all just as consistent as could be at 200k. So I guess we can check between the collector and the emitter now. And again, we're not looking for anything specific, we're just looking for consistency. And this is about all you can do to test it in circuit. And they're all perfect. There's no problem with the drivers at all. So if the ECU is the problem, then it's something other than the driver. Now, I know something about these ECUs that, you know, somebody that doesn't work on them very often doesn't know. And I do know that they have another problem. So let's go ahead and check for that problem now. And what we're going to be checking for is the resistance between the driver's collector and the output pin here. Because sometimes these particular units like to build up oxidation between the pad and the driver, tab, which causes higher resistance, you know, from the signal getting through the driver, through the board to the pin, which is to the coil. So let's check that. And this one is pretty easy to check, and I will show you how to do that. And this, anytime you're working on an ignition system and you don't see any visual error, any visual problems, and you don't see any problem with the driver itself on the board, you might want to check for this. All right, now the goal is to go from the collector through the pad to the output, right? So I'm going to come to this side of the tab, so I know that the resistance I'm checking is going to be all the way through. And if we look here, we see this little current sense resistor. We're going to measure to that, okay? And we should have virtually no resistance. Let me get the little meter here. Now I have my really nice probe, so we should see some really low resistance here. Okay, so I'm gonna go here, here, and there you go. You see really tiny resistance. And we're gonna do that for this guy. And this one comes to this resistor. And look at that. We have much too high resistance through here. That's not right. So that's probably our problem. Let's check this one. This one comes to this resistor here. And we see again our very low resistance. Okay, let's check these over here. This one comes to this resistor here. So let's check. That's good. Let's check this one. Good. And now let's check this one. Okay. So they are all good except for this one. And this one is very high. And if we look, actually, I can see the trace is kind of brown now. I didn't notice that earlier. But this one's kind of brown too. So maybe that's just the flux burning, or maybe that's just normal. I don't know. But if we come here to this side of the pad, you see where I'm probed there? And now we come here, you're going to see that low resistance again. That's what we should see. We shouldn't see high resistance. So something from the bottom of this driver to this resistor was causing high resistance. And look, now it's gone. That's weird. And all I did was scrape away. So maybe there's a break or something in this trace. That was causing it. That's pretty odd. Never seen that before. But that would still cause a misfire because the current sense would be off. All right, well, let's take this one off and see what's going on under it, because maybe just scratching around and I've done something. Now, typically you would want to add flux, and you would want to, use your iron to try to help get this off. But I'm going to use just hot air because I want to try to see underneath of it. Sometimes if you take it off with just the hot air, you can see how bad it was oxidized. Sometimes it's oxidized so bad that it burns the pad up completely. But other times it doesn't really hurt the pad. It's just the solder has gotten really brittle and oxidized, I guess, from the heat cycling of the driver. Yeah, see, there we go. You see how that is all messed up? That's not normal. It should not look like that at all. Let me pull these other ones off so we can see what a normal one looks like. That one's actually kind of oxidized as well. Let me take this one off. It's not too bad though, because you can see the shiny bits still making a good connection. But this dark bit, that means the connection is not that good. And this is probably a lot to do with using lead solder instead of, using lead-free solder instead of the lead solder. And whatever lead-free solder they use, it must not be a very good one because, oh man, look at that one's messed up too. None of that is what it should look like when you take them off. So I wasn't planning on doing all of these, but let's go ahead and do these too. Because something's definitely not right. Oh, no, see, this side is good. See, that's what they all should look like right there. They should be nice and shiny. Anyway, it's definitely because of the solder that they were using at the factory. I mean, you can see the difference there. It should look like this, not like this. And this is 100% our problem, and this is why we had the high resistance coming through this resistor. I'm surprised we didn't have high resistance coming through the rest. I guarantee you if we put some type of load on there, you would have saw it better because there's just a lot less surface area there to get the load, to get our load through. But let's see if we can't get it cleaned up. I'm gonna put some flux here. This is Kester 1544. It is designed for heavily oxidized circuits to help with. It's very aggressive flux. Okay, I'm also going to get some lead solder here. And I want to try to just clean up the oxidation so I can just keep using the same pad. I don't want to try to redo the pad. So I'm just going to keep here trying to apply the lead solder and letting the flux do its job. This one looks pretty bad, so I don't know how it's going to go. That one's fine. This one's fine. These are all fine anyway. So this one may be gone actually. It is. It's gone. Look at that. I don't think no amount of flux and solder will fix that because it's just flat out gone. Now these boards are very thin, so I don't want to go digging through here, right? So we're going to have to come up with something to make sure that we have a solid connection. Maybe we can restore this one a little bit. No, I don't think so. Not under the microscope, it don't look as bad, but under the microscope, it's pretty bad. Let me try a little bit more flux and solder. And I'm going to scrape a little bit. Might get a little bit off of there. I thought the pad was gone, but it looks like most of it's still there, and it is just oxidation on the top. Sometimes these get so bad that they just eat right through. Okay, we're getting some of it to come back. And this is extremely hard on your tip, so if you're not somebody like me who does a lot of work like this and considers tips disposable, then you don't want to be doing this with your tip. It's very very hard on them. But like I said, I do so much of this kind of stuff. I treat my tips as disposable because for me, it's more benefit to, just continue with my work with whichever means is possible than to worry about my tip's durability. Yeah, see that is just gone. So we're just gonna keep cleaning this up here. Let's get rid of some of this stuff. I think everything else is pretty good. It's only this one, and I don't think there's gonna be much else we can do to recover it. Tell you the truth. Let's clean it up real good and see what we finally got here. See, this is the part of the pad that's actually gone. Has deteriorated away. Let me see if I can zoom in a little bit better. See, the stereoscope, I can see that it's eaten away. The camera, you don't really have depth perception, so you don't know if it's just some trash on top of it or if it's deep in the board. But yeah, it is going deep in the board. So here's your dilemma. Do you say, well, this is a lot of surface pad left. Should I just put the driver down or should I put something here? And, you know, I don't know if there's any wrong answer. I think you could kind of go either way. Like I said, these boards are really thin, so I don't want to go digging through here. And, I mean, what's the point of putting a little tiny piece of copper here? The the tab on the driver is, a big piece of copper anyway. So I think we might just roll with this. The connection is here. They go through these through holes. So I think as long as we use some good solder here, I don't know. Now, see, now it don't look as good. I think we're going to go with it like this. Yeah, I think we're going to go with it like that, but we're going to push the driver up forward a little bit so the majority of the driver sits on this front spot here where the actual connection is. So like the pad back here, you're just trying to get a larger area for the tab to sit on. So you see the tab here? I'm going to scoot the driver up so that the main connection area here is connecting on this spot. So if we hold this up, we can see we have to come up about this high. So our little legs will come past this a little bit, which is fine. Just like that. Now let's add a little flux here. And let's see what we can do to get this guy down. And it doesn't matter if we touch this resistor because this is the resistor that we need anyway. That is the resistor for the base there. Let's go with that. I like that position there. The damn thing keeps sliding around on me. I'm going to try one more time to get it in the position I actually want it, which is right there. Okay. Now, You know, it's not the best, it's not the prettiest, but we are not trying to win any beauty contest. We're just trying to make it function. All right, and let's go ahead and do that. There we go. We'll go ahead and clean this up again, and then we're going to finish the other ones. Other ones are no problem. They're just going to go down like normal. I'm trying to fix my focus there a little bit. Something's got off with my camera. All right. So I'm going to tin all these pads like this. And we're just going to start throwing the drivers up. See, we need 5 more. Got 1, 2, 3, 4, 5. All right, we're going to drop some flux here on all of them. Just going to grab them now and put them in place. Just like that. That's good for that one. Good on that one. Uh-oh. Tweezers keep slipping. Good on that one. So some of these aren't good. I'm going to have to come back, but I just want to kind of set them right now. Whenever you see the solder kind of bubbled out the back, that means it didn't sit well. You really want to see that solder getting drawn under. So we're going to come back through these, but I want to place them first to make it easier, and then I'll come back with a little hot air over top of them to kind of reflow it. My hand's not very steady this morning. That's kind of the problem here. My tip on this iron's starting to go bad too. It's about time for me to replace it. All right, so let's put a little flux down again. Okay, I'm gonna get my hot air. And let's start on this side here. Okay, perfect. Just let it pull itself into place like that. That's good enough for me. That one I pushed it a little bit, but that's okay. All right, let's hit this one. Okay, now that one, I don't want to hit that one too much because I already got it set where I want it. But let me just touch the back a little bit. There we go. So now I'm pretty happy with that. I just have to clean it up. Try to get that flux off of there. And I'm just using IPA to clean it. I have some flux remover spray here. That's supposed to be perfect for this type of flux, but you know, truthfully, the IPA works pretty much just as good. Then, you know, smells a lot better than this one. This one stinks pretty bad. All right, so we can test again. we're gonna do the base in a minute here. 15, 15, 15, 15, 15, and we're gonna see 15 again here. All right, now I'm not gonna do all of the testing, but I am gonna do the tab here, through the tab to check to these resistors, like how we found the problem. So look how low that is now. That is beautiful. Look, damn thing went negative. That's how good it is. It went negative resistance. Okay, let's go back here. And there we go. 0.02, that's fine. Something's not, oh, I had the wrong one. And there we go. Yeah, that one's pretty low too. Let's check these ones. There we go, 009, 010. I think that's what I'm used to seeing is right around 010. And where's this one? This one's right here. There we go. 008. Yeah, I think that is good. I want to check this. This guy looks like it's missing some solder on that resistor there. I'll go ahead and touch that up a little bit. Last thing I need is a repair to come back because the little base resistor was not making a good connection. And yes, that has happened before. That's why I know to touch it up. Uh-oh. That don't matter because that is the connection for that. So I'm actually going to leave that. All right. I'm happy if you're happy. So I'm going to actually call this one. Um, I will, hook it up and test it there. Just do some basic testing, but I think that is pretty much all we need for this one. I hope you guys enjoyed the video, and I'll catch you on the next one.